Yeah, fine. So basically, today we are about to start the third workshop with the new experiment. Yeah, yeah. But today we have BSc second year slot. So this is your third semester, right? BSc second year. So there
Yes, ma'am.
are a few experiments which are included in your virtual labs. This is for all of you. Mhm.
So, I would like to introduce our speaker, Dr. Aparna Dikshit. Aparna Dikshit is Associate Professor in PSIT Kanpur in Physics. She has many experience in teaching and research. She has also national and international publication. She has her experience in virtual lab also. She will express the experiments among you prescribed by National Education Policy 2020 and that syllabus provided by Mahatma Jyotiba Phule Rohilkhand Vishwavidyalaya Bareilly. So I would like to welcome Dr. Aparna Dikshit Madam. Is
Thank you, sir,
my
for
principal
bringing.
Dr. Shraddha Madam is available? No, अभी शायद मैडम नहीं आई हैं.
Yes, sir.
तो
Yes, sir.
मैडम
Namaskar,
मैडम
sir.
इज अवेलेबल है ना. So I would like to request Dr. Shraddha Gupta. Please let me the permission to start the workshop and welcome all the participants. Dr. Madam.
Please, sir. Go ahead, sir. Go ahead, sir.
Thank you. Thank you. Madam, let we have to start it.
Yeah, because we have limited time, so without wasting our time, let us start the workshop. Okay. Uh, Actually, at 12, I have another assignment also. We have a meeting at 12:15. All right. So, regarding NAC and other work. So, let's
Namaskar.
perform the experiment again. We
Namaskar.
will go with the same site vlab.co.in, and then you can see the broad areas of virtual lab. Click on physical sciences. Fine. So again, page is not found. Some problem is there. We can try again. I'm sharing my screen. Can you see my shared screen?
Ma'am.
Okay, fine.
No, ma'am.
Can you see?
Yes, ma'am.
Okay,
Yes,
fine.
ma'am.
Nowadays, actually, this website is experiencing some problems. Determine the We will study the variation of magnetic field and then to estimate the radius of the coil. But here we will study the variation of magnetic field. So this is part of magnetism. So let us choose electricity in magnetism. Again, it is prepared by Amrita Vishwavidyalaya. Okay, so you can see tangent galvanometer, magnetic field along the axis of a circular coil. So here we have to study the variation of magnetic field with the distance along the axis of a circular coil, current. So there are few experiments. You can see Anderson bridge Quink's method, temperature coefficient of resistance, Bargausen effect, Venn diagram generator, deflection magnetometer, and so on. But these two are included in your virtual lab curriculum. So out of these two, actually, we are performing this experiment, magnetic field. You can go through with the theory to study the variation of magnetic field with the distance along the axis of circular coil carrying current. Okay. So generally in our respective lab, actually, we normally uh, estimate the radius of the coil also. If you remember, I think so. It may be in the physical lab also your जो available है आपकी lab, ठीक है? So you can see circular coil, compass box, emitter, rheostat, commutator, that is four-way plug key, cell key, connection wire, है ना? So purpose of what is the purpose of the cumulator? Just to allow the current in uh, to be in the reverse way, as in the same direction throughout the circuit. Okay, so we will keep the direction of current in one way, in opposite direction. Okay, so let us revise some theory here. So we need to choose a current carrying coil generates a magnetic field. So if we apply Biot-Savart's law here, so magnetic field at a point due to this current carrying coil is directly proportional to the current flowing and directly proportional to the length of this element of wire, directly proportional to the sine of angle theta between the element, this one dl, and the line joining the element to the point, and inversely proportional to the square of distance between the element and the point O and the element. Okay, so here you can see dB is nothing but a mu naught upon 4 pi into I dl over x square plus r square, and then you can see the formula for basically B is mu naught Ni over 2 r square upon x square plus r square to the power 3 by 2. So the distance x basically you are changing as per your requirement. N is the number of turns in the coil. Mu naught is the permeability in free space. I current which flows across the coil when it is magnetized. So now if you go with the procedure, so you can see this arrangement. This is actually tangent galvanometer. On either side you can see some scale. So this is nothing but Stewart and Gee type tangent galvanometer. This one is nothing but accumulator, and you can see here the uh, either you can use eliminator. Without using the cell you can battery you can use actually eliminator, so that what does it do? uh, AC current will be coming to it, and then it will convert it to DC. With the help of rheostat, you can change the value of current on a emitter, and then this is the one-way plug key. This is the rheostat, so variable. So you can change, you can vary the amount of current through this coil. Okay, so this is four-way plug key through which actually you can accumulate the current in a one way in opposite direction, so that the pointer, suppose the current is flowing in this way, what will happen when the current flows through it? So flux will change in each turn of the coil. This is inductor actually. So you can see this is actually coil of n turns. Flux will change with the change in time. So this change flux will induce an EMF, and induced EMF actually will set an electric field whose direction will be, जिसका direction क्या होगा, tangentially parallel to the direction of current. Suppose current is flowing in this way, so tangentially parallel like this in this way. Okay, right? So when you change the direction of current here, so again the current will flow in this direction, like anti-clockwise. So the direction of electric field will also get, electric field will set in another direction. Okay. So here we are following the Faraday law of electromagnetic induction also, right? Which you have already, I think, studied in your class 12th. So four basics laws of electrodynamics, right? Gauss law of electrostatic, Gauss law of magnetostatic, and Faraday law of electromagnetic induction theory. Fourth is Ampere circuital law. So we are applying here Faraday law of electromagnetic electricity. Okay. So now we are moving ahead. Just go to the procedure. Circular coil apparatus. This is actually. Okay. So we need here compass. So this is nothing but a compass box, which is consisting of pointers. And at the point of suspension, you can see pointers are associated with them, and magnetic needle is also mount there. Okay. So now you can see the procedure for real lab. So in real lab, what we do initially, coil is fixed at the middle. So we just keep the compass box at 90-90 and then rotate the bench so that the pointer stays at 0-0. Okay, then we close the circuit, and then we set the, when we set the pointers at 0-0, pointer को जब 0-0 पे set करते हैं, then you can see when you close one of the eye, so you can see along the direction of basically pointer, you can see basically all are in same vertical plane, like pointers and magnetic needle, all will be in same vertical plane, right? इसका मतलब ये है कि if you keep it at when the current is not flowing, देन बेसिकली जो मैग्नेटिक निडल है वो कहाँ पे स्टे करेगी? अगर हमारे पास कंपास हो और हम अपने इस एटमॉस्फेयर में रखें, सो इट विल शो द डायरेक्शन ऑफ व्हाट? क्या डायरेक्शन शो करेगा? किसकी डायरेक्शन शो करेगा? कैन यू प्लीज टेल मी? अगर हमारे पास कंपास हो तो हम उसको हाथ में लें और उसमें जो पॉइंटर होते हैं मैग्नेटिक निडल के, वो कहाँ पे जाके स्टे करेंगे? वो हमें क्या बताएंगे? कंपास से
North and south.
north and south of what? We can have idea about the north and south of earth, है ना? अर्थ की मैग्नेटिक फील्ड का आइडिया में होगा कि उसका डायरेक्शन क्या है, नॉर्थ और साउथ डायरेक्शन कहाँ है, राइट? सो बेसिकली सपोज वी हैव जीरो करंट, वी आर अप्लाइंग जीरो करंट, सो जो मैग्नेटिक निडल होगी दैट विल स्टे एट द मैग्नेटिक मेरिडियन, मतलब यू आर सेटिंग डाउन इट इन टूवर्ड्स द अर्थ मैग्नेटिक फील्ड, अर्थ की मैग्नेटिक फील्ड में सेट करोगे. So you can see the north pole of your magnetic needle will attracted towards south of earth, and the south of magnetic needle will attracted towards the north of earth. Is it clear to all of you? ये सभी को clear हो रहा है? Okay. Then you can see the apparatus, जो कंपास बॉक्स है इसको हमने रोटेट करा दिया, एंड देन पॉइंटर को भी 0 0 पे कर दिया, सर्किट देन क्लोज, एंड देन वी कैन एडजस्ट द करंट. करंट कैसे एडजस्ट करेंगे? एडजस्ट द रेयोस्टेट. रेयोस्टेट को इतना एडजस्ट करें सो दैट द जो आपका कॉइल है उसका हमें थिकनेस निकालना है. कैसे? स्क्रू गेज से नहीं, विद द हेल्प ऑफ ग्राफिकल एनालिसिस. ठीक है, जो आपके रियल लैब में होता है. उसके लिए हम क्या करते हैं, हमारी जो थिकनेस है कॉइल की वो क्या होनी चाहिए? यूनिफॉर्म होनी चाहिए. तो इसका मतलब यह है कि हमें कितने एम्प करंट देना चाहिए? कम से कम इतना अमाउंट, सो दैट द थिकनेस ऑफ द कॉइल वुड बी रिमेन यूनिफॉर्म, यूनिफॉर्म बनी रहे. सो फॉर इट एक्चुअली डिफ्लेक्शन किसके किसके बीच में होना चाहिए? 30 से 60 डिग्री. जनरली वी प्रेफर 70 अप टू 70 to 75 in our lab. ठीक है. Then we note down the deflections, and then again we check the current. We can change the direction of current by reversing the current. We can again note down the deflections, two values, and then we can have the average of, at different distances, average of deflections, and then we can take out tan of each angle theta, and then we have a values between x and tan theta. So generally in our lab we place the magnetic needle at different distances, start from center x equal to 0, and you can see your scale is basically mentioned from 0 to 50 centimeter. So we can vary from 0 to 50 centimeter. बट हम कहाँ तक कर सकते हैं? 30 डिग्रीज तक डिफ्लेक्शन. सो कैन नॉट बी गो बियॉन्ड आई थिंक 18 और 20 सेंटीमीटर. राइट, दैट मीन्स हमारे पास काफी सफिशियंट ऑब्जर्वेशन हो जाएंगे, एंड देन वी कैन प्लॉट अ ग्राफ tan theta x versus tan theta. Okay, basically now you can see the procedure for doing the simulate. तो यहाँ पे जो वर्चुअल लैब एक्चुअली अवेलेबल है, in this actually we have to follow the steps in the simulator. Okay, so what are these? So here actually we can see first preliminary adjustment should be made in order to properly align the operators. Initial adjustment, just try to read out these bold statements. Initial, the button initial adjustment is provided for this process. Experimental apparatus will be fully active only after the initial adjustments. Once you click on the initial adjustment, so basically your experiment will be active. Then remember, on clicking the initial adjustment button, you can see the zoomed view of compass box. So when you go for the zoomed view of the compass box, you can rotate the compass box as well as you can rotate the apparatus itself, just to maintain 90-90 and 0-0. Okay, so using the slider rotate compass box actually 90-90 rotate karega, and rotate when you rotate apparatus, so basically the pointer will stay at 0-0. So 0-0 तक हो गया हमारा. Then you need to click on show normal button in the simulator, and then we will go back to the experimental setup. Then we will make the connection भी तो करने होंगे, as shown in the diagram, circuit diagram. So this is the circuit diagram. Accordingly we have to connect the connection wires between the appliances. Right, so here you can see make the connection, and then connection wires from terminal of each component. When a hand symbol appears there, जब symbols आएंगे, then we can make them connect. Close the circuit using the button insert key. फिर insert key से हम क्या करेंगे, circuit को close करेंगे. Then we can zoom the compass box. We can select the number of the directions